All of these are outlined. We could spend hours, weeks, months talking about all the details and all the reasons behind all these requirements. But what the requirements do is they allow you to run a fully intelligent, highly connected shop, but run it in a way that doesn't violate any of the government requirements of how data is accessed, transmitted, or shared. Sure, I'm William Harvey, EVP of Software Programs at Aura Technologies. Aura Technologies, some people call them a cyber shop. We're a research and development shop. We provide technology development services for uniform branches of the uniform branches of the U.S. military, DoD primarily, and we do a number of different projects for R&D and also commercialization efforts. So in the past, people could say, oh, self-attestation, sure, I'm compliant, sure, I'm certified. They weren't really certified, they were doing a self-attestation. In today's regulatory environment, you have NIST 800-171, you have other NIST requirements, you have CMMC 2.0. They no longer allow you to do self-attestation because too many people were lying. What this requires is now you have all these controls that you have to follow. And if you go to try to submit a bid for a contract, it will say in the contract the company must meet the following requirements. There's things that are called FARs and DFARs, that are FARs and DFARs, that are requirements for purchasing and delivery of contracts. A lot of people don't pay very much attention to those. They're now becoming a big deal. You will not be selected if you do not have CMMC compliance. You can't even bid. So people will be required to show that certification. But instead of attesting that they meet those certifications, they have to have what's an independent assessor review and confirm that they meet those requirements. So it's really changing the landscape. It's making it so you have a smaller group of more serious people that are qualified to bid on projects and contracts. And when they go through the contracting process, if they fail to meet any requirements, they'll be rejected from the process and disqualified for future bidding. So it's really changing the landscape. So there are two driving forces that are directly opposed to one another. One is connectivity and one is compliance and regulation. As we're moving into Industry 4.0 and everybody's connected and everybody's sharing data, everybody's downloading information and updating and so on, you're sharing all your data, and that's a huge problem because when your machines are connected, that means you have a larger attack surface. So what the regulations or what the CMMC requirements are things that control how you limit the data that's shared, how it's shared, when it's shared, and in some cases you're not allowed to share at all. So you have to have protective barriers up between what you do and don't transmit externally. All of these are outlined. We could spend hours, weeks, months talking about all the details and all the reasons behind all these requirements. But what the requirements do is they allow you to run a fully intelligent, highly connected shop, but run it in a way that doesn't violate any of the government requirements of how data is accessed, transmitted, or shared. Those two things are constantly a tug of war. One example is you have a machine tool. It's a brand new, super modern machine tool. But that machine tool goes back to the mothership and it asks the servers at its manufacturing office, what is the right mix for this particular batch of powder? Well, that communication is not really allowed, because if you're making a military part, they don't want the fact that you're making a military part to be communicated out or transmitted out. And this becomes an attack vector, because if you have a foreign state that's trying to hack into that particular type of machine, they're going to be watching what all the machines of that type of manufacturing, where they are, how they're doing it, how many they're doing, and you don't want to be sharing that information with your government adversaries. So you put all those together, you have to have a manufacturing shop that has all the benefits of modern connectivity and modern technology, but does not openly broadcast what it's doing to everybody all over the world all the time. So resource low and resource high, those are qualitative ideas of suggestive of what is little, what is a lot. You say, oh, I have to spend $10,000 to become compliant, but now I can do a project that's worth $500,000 or $1 million. So spending $10,000 to do $1 million project is very low resources. However, for a shop that only does $100,000 a year of business, spending $20,000 is very resource high. So the perspective that we have at Aura is, if you're going to play in the big game, you have to be able to invest and build and deliver on the big game requirements. It's kind of like saying if you can't ante up, you can't play the game. Now, if you're a small shop and you want to grow your business and you are interested in pursuing government contracts, or if you're interested in pursuing contracts that have these requirements attached to them, you have to meet the minimum. You have to hit the table stakes. You have to ante up. Now, the trick is, how do you meet those table stakes while spending the least amount of resources to do so? And the way that we found that to be the success path to that is minimize your footprint, minimize your compliance requirements, minimize the amount you have to spend to become compliant and maintain compliance, and maximize your ability to bid and close work for future expansion. So Aura as a company, we have evaluated reseller, Philips Federal. Now Philips Corporation has a long history of both commercial and government contract support. And therefore we don't have to provide a fleet of service technicians in the field. We don't send dozens or hundreds of technicians out or salespeople out to go do things. We provide a solution. The solution that we provide is, we call it the trusted DM, trusted digital manufacturing, trusted endpoint. And what trusted DM does is it creates a barrier between a compliant network and a non-compliant network. It's a digital air gap that allows you to have a digital enclave where you have an untrusted machine tool that's connected to a trusted network. That trusted network can be a government network, which is called NIPRNet, or some other government network, or it can be another compliant network. Other companies solve this by putting up a firewall or a set of firewalls between a production area network and an IT network, or between industrial controls network or an ICN and an IT network. We have a device that can either be a bridge from an IT to an OT network, or a bridge between an OT control to an OT fabrication network. That's the solution that Aura provides. There are other solutions out there. We know by practice they're inferior solutions. How long does it take to become compliant? In order to install an Aura box, it takes 15 minutes. In order to install a piece of machine tool with integration and so on, 30 to 90 days. In order to take a network from zero to compliance, depending on how big your network is and how much you can retool in order to stand it up, anywhere from 30 days to 6 months. Why is our box not a firewall? If I have an IP network and an IP network, that's Internet Protocol or TCP/IP network protocols, if it bridges from one network to another network and it flows through a device called a router, that's routing traffic. That's what most people have at home. They have a router. If you want to put up a barrier that allows traffic to flow one way but not the other way, or have rules around it, this is typically called a firewall or a firewall appliance. If you want it to go and have it detect if it's been attacked or to stop people from attacking it, it becomes an intrusion prevention system or an intrusion detection system, an IPS or an IDS. The Aura box is none of those. The Aura box is a media gateway. It sits between an IP network and a machine tool, and the traffic is not routed as IP network. It actually changes forms and crosses over a digital air gap, so that we're not routing with a router or a firewall traffic from one network to another. We're actually a barrier, like a canyon, with a gateway that goes from one side of the canyon to the other side of the canyon, which is why we're able to do the things that we do. No information goes over the canyon at all unless we designate it as it's allowed to, which is very different than a firewall or an IP router. So an IP router takes all the traffic. Most people are familiar with the router they have at home. You have your home network and you have the internet network. And that router decides if it's going to send traffic from the home network to the internet or not. And whatever traffic comes in from the internet, it usually does not flow into the home network unless you're on the computer that made the request for the data in the first place. Usually, not always. Now, the idea there is we don't provide a firewall capability. We're not trying to be a firewall. We're not trying to let everything through and decide what doesn't flow. We let nothing through. And then we very specifically designate only the safe things can flow. This is what allows us to claim our compliance or claim our air gap, because nothing flows. There is no IP to IP connection. We terminate the connection, we look at it very carefully, and then we're able to choose what data is pushed over to the other side. That's why it's a digital air gap. An ATO, which is an acronym for Authority to Operate, if you have a piece of equipment and you want to install that equipment on a federal government network, the process is different but similar for Department of Defense, Department of Energy, or other government networks. You must have authority to operate. The government can't just go down to Best Buy and buy a piece of equipment and plug it into the network. It has to be reviewed and approved. And that review and that risk management framework process, that RMF process, leads to what's called an ATO, an authority to operate. It is not possible to take a bunch of random machine tools and authorize all of them to work, which is why you will never take shop tools and plug them into a government network. They will always be segregated or isolated or disconnected in some way, shape, or form. The devices that you see that do have ATOs are types of computers, various tablets, certain types of firewalls. But if you're going to plug any network device into a government network, you must have an authority to operate either locally or globally, or the government will not let you plug those devices in. If you have a STIG, S-T-I-G, this is the working group that creates a set of requirements of how you must set up or configure a device, like a Windows computer, in order for it to be connected to a government network. And the STIG is changed every 90 days. So every 90 days, there's a new set of requirements. So they may have a requirement that says if you don't touch the computer for 60 seconds, it has to be signed out. If a computer does not have that control installed on it, it won't pass the STIG. Or when you press Control-Alt-Delete to sign in, it has to clear the clipboard buffer, so somebody can't copy-paste and paste what you put in previously. These are all controls in a STIG. STIGs have different levels, low, medium, high severity. But in all cases, those STIGs are republished every 90 days, and in order for something to be compliant within a STIG, you have to have a method by which you can update your system a minimum of every 90 days or more frequently. The problem with putting STIGs on machine tools is most, not quite all, but most machine manufacturers don't have security update cycles of 90 days or less. They have update cycles of years or dozens of years. And they only do an update if there's something catastrophic that they have to change, like a firmware change or a hardware change in their system. So most machine manufacturers don't have regular frequency or periodic updates of their security. So you will not have a STIG for a machine, but you do have a STIG for like a Windows computer or something like that.